Hey, Earth Science people. It's Jordan here. Today we're going to do astronomy number 4 in our very, very shortened astronomy unit. So today we're going to talk about gravity and the solar system. And this is a nice little animation kind of giving you the idea of the solar system. But as you'll see today, and we'll talk about a little bit, this is, of course, not really to scale because the distances in between spaces are much, much bigger than this. All right, so we're going to start by talking about gravity. Gravity is probably something we've all talked about or understood a little bit. And most people think about gravity as the thing that keeps us on Earth, right? If you drop something, it falls to the surface. So why is that? Well, it's actually not just a downward force. Gravity is the force of attraction between objects, right? So everything that has mass creates gravity. So even you, right? You create gravity. Now, your gravity is not big enough to pull objects towards you, especially because you're on the surface of a much more gigantic object, the Earth. But technically, because you have mass, you create some gravity. So all objects with mass have gravity. This is a very famous experiment here. It's called the Cavendish experiment. So basically, this is a long rod that has two very small metal balls that have mass, and this rod is suspended by a very thin wire, so it's hanging freely. And you'll see that the rod is actually being pulled towards these gigantic or more massive objects, these large bowling balls. And you can see that the massive objects are pulling the smaller objects towards them. And this is the most important concept for gravity for us to think about, right? So there are two things that are going to impact the gravitational pull or the gravitational force. One is the closer the objects are together, the greater the attraction or the greater the force. And the second is the greater the mass of the object, the greater the force. So put simply, large things are going to pull smaller things towards them. Okay, so here's the way that the Regents would ask you something like this, right? They would give us two planets, one with a mass 5 times of Earth and one with a planet 9 times Earth's mass. And it wants to know which combination would create the greatest gravitational or gravity force between them. So remember, we just said bigger makes more mass. So these fives, they got to be out. So now we're between 3 and 4. Okay. And then we said the closer things are, the stronger the attraction. So which one shows the biggest planets and being closest together? Hopefully you said number 3. All right. So this is just this is an important concept for us to understand the motions that are happening. Here's another GIF kind of giving you an idea of all the different objects that are moving around in our solar system. So a satellite can be said to be any object that revolves around another, and gravity is the force that is keeping planets and all these satellites in orbit. Something you might need to want to know is that planets move fastest when they are closest to the sun. And the same thing with comets or anything else. They will actually speed up when they're a little bit closer. So that means the things that are closest to the sun are the things that are going to be moving the fastest around. That also means the planets that are farthest away from the sun are going to be moving the slowest around the sun. So which planet do you think moves the fastest? All right, if you know which planet is closest to the sun, that is Mercury, and that is the fastest moving planet. So now let's break down some of the objects in our solar system, okay? But first, let's define the term solar system. The solar system is composed of our star, which we call the sun, and all the planets, which we're going to name and list today and talk about, and then also the asteroids, which we can kind of see faintly here, okay, in a belt between Mars and Jupiter, and then also comets, which are sometimes really, really far away, and then we'll loop in past our planets and then go back out around the sun. So everything that is the system around our sun, or everything that is orbiting around our sun or being pulled around our sun by its gravity, is called our solar system. So the solar system was formed about 4.6 billion years ago from a gigantic cloud of dust. We call this a nebula. And that nebula collapsed in on itself, and gravity pulled those dust pieces together. Most of the dust from the nebula created our star, the sun. So 99% of all that dust got pulled together and ignited and created the sun. We'll talk more about the formation of stars next week. And then the rest of the dust from that massive nebula formed planets. There are two different groups of planets. We call one group the terrestrial planets. These are small and rocky. And then the other group is called the gigantic gas planets or the Jovian planets. So this huge nebula collapses on itself. It makes our star, it makes the planets, and it also makes smaller things, right? Leftover dust formed into asteroids, and it also formed into comets. And when astronomers are trying to study or talk about the old solar system, what was going on 4 billion years ago, of course, humans weren't there, right? Our planet was barely formed. So the way that they study and know about the early solar system is they look at these older pieces of rock like asteroids and comets. Okay, this is a really mind-blowing image to me. This is an actual scale size of each planet and our sun. So first, let's just look at how gigantic our sun is, right? The star, like I said, it contained 99% of all the matter in the solar system. So it's huge, right? And then this is Jupiter. Here's our planet, Earth. So I remember I told you there were two different groupings of planets. So these are the terrestrial planets. They're smaller and they're mostly rocky, right? And the reason that they're so rocky is they're closer to the sun. So the sun burned off the gases that could be formed these planets out here. So the Jovian planets, these big guys, they're also called gas giants. They're far enough from the sun that the sun's temperature does not burn off things like methane. So methane can be in its gaseous form. It can be collected, right, by these planets, and that's what made them so gigantic. So these are the two different groups. Here is the new solar system data reference table. It's on page 15. You're going to use this to answer any questions about the planets. Okay, so find it on page 15. It's our second to last table for the entire year. I highlighted the Earth here. So this is us, right? We're on this planet. And let's just break down the columns real quick. The first column is the mean distance from the sun, or how far away is this planet from the sun. So you can see we're going from closest to the sun all the way down here, farthest from the sun. Notice they put the moon down here. So the moon is they just added that onto the end. Neptune is the farthest planet from the sun by a long shot. All right, the next column is the period of revolution. You might remember revolution is the trip all the way around the sun. So we would call this a year for Earth, right? 365 days. These are the years for other planets. So notice as you get farther from the sun, it takes a lot longer to get around. The next column is the period of rotation. We might call this the day, right? So how long does it take for a planet to spin around once? Earth is just about 24 hours. You can see some planets have a longer, right? The planets closer to the sun, like Mercury and Venus, have a much longer day. It takes them a really long time to spin around once. But as we get farther from the sun, those gigantic planets are spinning very, very, very rapidly. Okay, so they have shorter days than the Earth. The next column is eccentricity of orbit. I'm going to leave that alone. We're going to leave that alone this year because of our shortened schedule. But I will just say that this number is about how flat or circular is the orbit. So the higher the number, the less like a circle the orbit is. This is the equatorial diameter column. So this just means how big across is the object. Notice how massive the sun is, right? Here's Earth by comparison. Okay. The next column is mass. Kind of think about mass like matter. We can think about it as really as like kind of like weight a little bit, although that's technically not correct. So what they're doing is they're comparing every planet to Earth. They gave Earth a mass of 1 here. So the sun is 333,000 times more massive than the Earth. These planets are smaller than the Earth, and these planets here are way bigger than the Earth, right? Jupiter is 317 times bigger than the Earth. And the last column is density. Remember, we talked about density a lot this year, but basically density is about how packed something is, how much mass per volume. So these planets inside, right, these planets have a pretty high density, whereas planets like Jupiter, although they are gigantic, they're not very massive because most of what's making them up is gas, and gas is not very dense. All right, let's go in a little more detail now. Here's our definition for terrestrial planets. Terrestrial means Earth-like. These are smaller, rocky planets that have high densities, and they are closer to the sun. And because they're closer to the sun, they got that gas burned off of them. Let's go into a little more detail. Here they are grouped out on our solar system data. Notice their high density and relatively small size, all right, in diameter. across. So here's a picture of Mercury spinning. It's the closest planet to the sun. It is the smallest planet. It takes a very slow rotation, partially because the gravity of the sun is slowing it down. It has a relatively quick revolution, right? It gets all the way around the sun in just 88 days. But because it's spinning so slowly, it heats up really hot, up to 819 degrees on the side that is facing the sun. And the side that is not facing the sun gets very, very, very cold because it takes a long time to turn. So it can get down to negative 279 degrees. So definitely not a place that we would ever want to live. There is no atmosphere on Mercury, and it has no moons. Here's a picture of the sun. Can you see Mercury? There it is. Super, super small, super, super close to the sun. All right, here's a photo of Venus. Doesn't look very interesting. Venus is the next closest planet to the sun. It is about 67 million miles. It is slightly smaller than the Earth, but they're very close in size. Sometimes people will call Venus Earth's twin. Interesting fact about Venus, it rotates backwards. So it rotates the opposite direction. Scientists believe that might be because it was struck by an asteroid and that spun it the other way. So it is a very, very, very slow rotation. In fact, its rotation, or its day, is longer than its year. It gets around the sun in 224 days, but it only rotates once every 243 days. Another crazy fact about Venus is it has an extremely thick atmosphere, which has caused a greenhouse effect that is so high that the temperature minimum on this planet is 818 degrees. And so that's so gaseous. There's so many clouds trapping the heat inside. This is what Venus looks like. If you take away the clouds, this is what you would see. Right? So it's a rocky planet covered in these kind of volcanic gases trapping heat on it. This is one of the only photos of the surface of Venus taken by a Russian probe back in the 70s. This probe landed, took these pictures, sent it back, and then the probe got too hot and it doesn't work anymore. Right? So this is a pretty crazy picture. Once again, not a place you'd want to live. The next planet out is our planet, the Earth. Here's a picture of Earth from the moon. You kind of get a sense of how small we truly are. Remember, Eric said in the last lesson, you can fit every planet in the solar system between the moon and the Earth. Right? So there's a lot of space between us and the closest object, our moon. Next out is Mars. So Mars is about 142 million miles from the sun. It is smaller than Earth. It rotates similarly speed to the Earth, a little over 24 hours. Its revolution is longer, right? It's farther out, so it takes longer to get around the sun. 687 Earth days to make its trip. It has lower gravity because it is less massive. Remember, smaller things have less of a gravitational pull. So that means the weight of a person would be less on Mars. If you weighed 100 pounds on Earth, you'd only weigh 38 pounds on Mars. We've been to Mars, right? We've sent, not people, but we've sent satellites and rovers to Mars. This is a picture of Olympus Mons, which is the largest volcano in our solar system. It is over 3 times the height of Mount Everest. So here is Everest, right? Here is Olympus Mons, 3 times its height. It is actually still active. Okay, here's a picture of it from space. It is a huge object. It actually sticks almost out of Mars' atmosphere. There is dry ice, frozen carbon dioxide at Mars' North Pole. Here's a picture of the Martian sunset, right? So this is what the sun looks like from Mars. Why is it so much smaller and dimmer? Well, because Mars is further away from the sun. Okay, here's just a cool picture showing Mars, Venus, and our moon all in one photograph. Moving quickly. Next up, between Mars and Jupiter comes the asteroid belt. So this is an area where the most asteroids are located. So you can see down here, right, all the planets spinning around. The asteroid belt falls in between us and Jupiter, okay? This is just a picture of Ceres, which is a very large asteroid. It's actually bigger than Pluto, okay? The next grouping of planets is called the Jovian planet. So these are massive, right? Take a look. Here's Earth down here. Once my box goes away, Earth down here compared to these gigantic gas giants. So the reason that they're able to get so large, here they are grouped, right? Look at the equatorial diameter. Okay, they're 142,000 kilometers across. They're much, much bigger. There you go for a clearer picture. Much larger than our planet Earth. They're so large because they're really far away from the sun. So because they're far away from the sun, their temperatures are colder, and things like gases are able to be collected without being burned off. So this is a picture of Jupiter. You can see its different wind belts spinning around. Okay, this was taken in 1979. It is the largest planet in our solar system. It rotates once around every 9 hours, but it takes almost 12 years for Jupiter to make one trip around the sun. Jupiter is so massive, it has captured 67 different moons, and the four largest moons are big enough to actually have been seen by Galileo back in the year 1610. The most famous feature on Jupiter is its massive red spot. So the red spot is a storm. It's been brewing and going for at least 150 years. And the winds on the red spot are going up to 400 miles per hour, right? That's faster than hurricanes. And this storm itself is 2 times bigger than the planet Earth. Pretty incredible. Here's another of Jupiter's moons, Io. There's volcanic activity that we've seen on Io. All right. This is Ganymede, which is the largest moon in the solar system. Here is the size of the Earth's moon for comparison, and here is the planet Earth, right? It's a pretty big moon out there next to Jupiter. Here's another one of Jupiter's moons, Europa, and here's Callisto. The next planet out on our solar system tour is Saturn. Saturn is the second largest planet in the solar system. It rotates once every 10 hours. It takes almost 30 years for Saturn to make one trip around the sun. So that means that in your lifetime, Saturn has not even made it around once, right? You've probably made it around 15 or 16 times because you're 15 and 16 years old. Saturn hasn't gone around once. Saturn is most famous and well known for its massive ring system. And in addition to that, it also has 62 moons. This is the most distant planet that is possible to see with the naked eye. You can see it without a telescope. All right. Interesting fact about Saturn, its density is 0.7. That is lower than water. So if you could find a vessel of water bigger than Saturn, Saturn would actually be able to float. Right? It's that low in density because it's just made of gases. Saturn also has its own giant storm called the Great White Spot. Here's actual footage, right? Taken, I believe this was Cassini that found this footage. All right. Here's another image of the rings of Saturn, right? This is a grouping of rocks and ice particles. Here's an incredible photo of Saturn, its ring system, and this little dot here, that's our planet Earth, way off. I mean, actually, I believe that's the sun. Yeah, way off in the distance. Okay. Titan is Saturn's largest moon. It's actually bigger than the planet Mercury. It is the only moon that has an atmosphere. It has oceans of liquid methane, and this is one of the places where scientists think if there is other life in our solar system, this would be a good place to look. Another place that scientists have recently figured out might have life is another of Saturn's moon called Enceladus. So it's covered in ice. This makes it actually the brightest body in our solar system other than the sun. And there's liquid water trapped beneath this icy surface. And there are huge geysers that shoot bursts of water into space. And they think that the super hot vents of water might be a place where there could be microbacteria found in the future. All right. The next planet after Saturn is Uranus. Uranus is a weird one. It rotates on its side, so it's kind of hard to see because it's pretty featureless. But instead of spinning like side to side, or spinning from east to west, it sort of spins from north to south. All right, and they think that might have been caused by a collision with another body. It is 27 moons. It is, of course, very, very cold because it's far away from the sun. It has wings. It takes 84 years to make it around the sun. So it has not gone around once in my lifetime. And it was discovered only 237 years ago. The last planet in our solar system is Neptune. It is very, very, very big. It is very, very, very cold. And it takes a long time to make its trip around the sun. Its revolution takes 164 years on Earth to get around the sun one time. So it's really far out there, which is why its temperature is so cold. You can see it also has one of those crazy cyclonic storms, right? The Great Blue Spot. Next up, we can't forget Pluto, even though it's no longer considered a planet. Pluto is almost 40 times further from the sun than Earth. It is a even colder planet of negative 375 degrees. Even though it's so small, it still has captured 5 moons orbiting it. And the reason it's no longer considered a planet is because it has not cleared its orbit, meaning there are still other bodies that pass through its path, right? Other planets have cleared out their orbits by either collecting, right, or colliding with those things, but Pluto hasn't been able to do that. Just to give you a sense of how tiny Pluto is, here's Pluto compared to our moon and our Earth. So it's very, very small, right? This is why we don't call it a planet anymore. We call it actually a Plutoid. So this is the summary of our lesson. Remember, gravity is the force of attraction between all objects. More massive objects have stronger gravity. The closer objects are, the stronger their attraction. So the most massive object in our solar system is the sun. The solar system was created 4.5 or 4.6 billion years ago by a cloud of dust collapsing. Because our sun is so massive, everything is pulled by gravity around the sun, and we can group planets into 2 different groupings. The terrestrial planets of Mercury, Venus, Earth, and Mars, they are small, they are rocky, they are dense, and they are closer to the sun. And then the Jovian planets, which are Jupiter, Saturn, Uranus, and Neptune, they are huge. They are gaseous, made of gas. They are low in density, and they are far from the sun. All right, this is an amazing unit. So there's always a lot of awesome things for you to check out. Take a look at the slides. Click on some of these links. There's some really great things to look at. And please make sure to complete your check for understanding to show us what you know. All right, it's been good. I hope this wasn't too long. Hit us up if you have any questions in office hours. Take it easy, guys.